The network theorem used to determine the value of current, voltage and resistances at various complicated electrical network. With help of Kirchhoff's laws, we can solve the values of current and voltage on that corresponding network. There are two Kirchhoff's laws. The first one is known as Kirchhoff's point rule or current law. The second one is known as Kirchhoff's loop law or voltage law. Kirchhoff's point law or current law states that the algebraic sum of the currents meeting at a branch point is 0. In the figure 1, we have a branch point A where the current entering towards the point A is I1, I2 and I3, and the currents leaving from the point A I4, I5 and I6. Using the sign convention, we have always entering current is regarded as positive and the leaving current is regarded as negative. So I1 is positive, I2 is positive, I3 is positive, I4 is negative, I5 is negative and I6 is negative. And according to the law, that net sum of current or total algebraic sum of the current entering the point A becomes 0. So let us write this equation. So as we have defined, I1 is positive, I2 is positive, I3 is positive, I4 is negative, I5 is negative, I6 is negative. The total summation is 0. This implies I1 plus I2 plus I3 is equal to I4 plus I5 plus I6. This means the net sum of current entering the junction point A becomes equal to the net sum of the current leaving from this junction point A. Let us illustrate this law with help of another example. Here in this figure, this complicated network, we have two branch points A and B. So in figure 2, you see that there are two branch points A and B. At A point, I1 current is entering, I2 current is leaving from this point, I3 current is also leaving from the point, and I4 current is also leaving from the point. And at B branch point, I2 current is entering, I5 current is entering, I6 current is leaving, I7 current is leaving, and I8 current is entering. Let us apply now the point Kirchhoff's point rule to the point A, or the branch point A. As I have discussed earlier, the current entering to the point is regarded as positive and the current leaving from this branch point is regarded as negative. So here I1 at a branch point, I1 is positive, I2 is negative, I3 is negative, I4 is also negative, and the net sum becomes equal to 0. So this implies I1 minus I2 minus I3 minus I4 equal to 0, or I1 equal to I2 plus I3 plus I4. So the current entering to the point is I1. It gets divided into three parts, I2, I3 and I4, so that total current leaving becomes equal to the current entering to the point A. Similarly, we can construct the similar way, apply this Kirchhoff's first rule to the branch point B. Here you see I2 is entering, so it is regarded as positive and I5 is entering, so it is regarded as positive. So I2 plus I5 and I6 is leaving, so minus I6